In this video, we are going to talk about the first and second order circuits in electrical. So this is the one of the important thing which as an electrical perspective we need to know the basic and the advanced of first order and second order, and what is first order and which types of the first order circuits we have, and what is second order and which types of these we have. So let's start our lesson. So what is first order and second order? First order means there is only one element. Rather it's an inductor or it's a capacitor. There is only one element, rather it's only one inductor or one capacitor. It's called first order. And what is second order? Second order means the inductor and the capacitor is both in the same times in order. We call that as second order. And this comma, I put comma instead of this, I put comma. This is inductor or a capacitor. It's called first order, and second order means inductor and capacitor in the same time. It's second order. Which types of first order we have is, we have source free first order. I just want to tell you that the first order only. So I'm start with the first order circuits. Source free RL circuit, same as source free RC circuits. Then step response of RL circuit, step response of RC circuit. These four circuits we have in first order. And the second order we have step response of series RLC. Second order we have series RLC because it have both resistor and inductor and capacitor. So series RLC and RLC parallel So these are the basic of first order and second order. When we start which one by one, explaining one by one, you need to get a brief understand what is first order and second order. So I am starting with the first point. I am start with source free RL circuit. So I'm going to write the circuit, I'm going to draw the circuit. So there is no source, only a resistor R and the inductor L. So I took the current through this circuit I. So I'm going to put, I'm just going to note this is VR across the resistor and this is VL across the inductor. So I'm going to put apply KVL to the circuit. So what is KVL said? VR plus VL is equal to 0. We already studied about what is mesh analysis and what is nodal analysis. I'm using in here a mesh analysis. So VR, I put I into R plus VL. For VL, what is the inductor voltage? VL is equal to L into dA over dt. We already know this. If you don't know, you have to remember a voltage across an inductor is equal to L, inductance of an inductor, into di over dt. So I'm going to represent for the VL, I am going to represent L into di over dt is equal to 0. So I am going to arrange this for a characteristic equation. di over dt plus R over L into I is equal to 0. So it's been nearly like S plus R over L is equal to 0. It's a differential equation. So these type of differential equation have the answers of IT is equal to A plus B into e to the power ST. This is the answer type. We know from this here S is equal to minus R over L. So when we do further, IT is equal to A plus B into e to the power minus RT over L. This is the answer, but we need to find what is A and what is B. What is A and what is B? For that, we just need to put T is equal to naught. T is equal to naught. IT is equal to 0 is equal to 0 or IT is equal to not 0. There is only one resistor. For the inductor is 0. So IT is equal to VL over R. So there is VL and VS are equal. So I put V over R. So IT is equal to V over R. When we plug in here, we got T is equal to no. We got A plus B is equal to V over R. So this is our first equation. So when we plug T is equal to infinity, T is equal to infinity, A is equal to 0. T is equal to infinity, A is equal to 0 because I is equal to 0. So the answer of this is IT is equal to I naught e to the power minus R over L into T. I naught is equal to V over R because that says that I naught is equal to the 0 seconds the current. In the 0 second it have the current value of that value. So this is the source free RL circuit. So when we have an example, we understand that more part. So I'm just leave it here and I'm going the next page. Just I'm write the example. If you understand this, please pause the video and do this example and again come to that part. So I'm draw the question. 40 volts. That's a 2 ohm resistor and it's a switch. It's 12 ohm. Here it's a 4 ohm, 16 ohm, 2 Henry. So in T is equal to 0, the switch has been opened. Switch has been opened at T is equal to 0. The question is find the IT. Find IT. So the question is find the IT. So what is the current through this inductor according to the time? So how we started? First we analyze what's this circuit. It's source free RL or source free RC or step response of RL or step response of RC or what kind, it's second order or first order. What we have to do? First we need to analyze, is it first order or second order? First we need to analyze, is it first order or second? I already told that if an inductor and capacitor at the same time in a circuit, it's called second order. But in here only inductor is placed but no capacitor. But so what is this circuit is called? It's a first order circuit. And when T is equal to matter, that means when T is upon the 0, there is no connection between the inductor and the voltage source. So this circuit is called source free RL circuit. So we already know that what is the answer for the IT? IT is equal to I naught e to the power minus rho over L into T. IT is equal to I naught e to the power minus r over L into T. So the question was IT. These IT. So we need to find the I naught and the R and the L. So we already know that very easy to find the L. The inductance of an inductor is 2 Henry. So L is 2. We already we easily find the R also. The R is when T is greater than 0, it's open. It's open. So these R and voltage also are not in our mind. So we need to cut this part. This part we don't need. We only need this part. So 12 and 4 ohms are series for this inductor. 16 into 16. So 8 is the answer for this R. So we need to find the I naught. When T is equal to naught, what is the current through this inductor? So when T is equal to naught, this switch is on. This switch is on. So the current pass through this, and through this. There is no current pass through this way because there is no resistance in this part. So the all currents are gone this way. So when we solve these currents, we come to a conclusion. The I across this inductor is when we solve this, we have to find that I is equal to I naught is equal to 6 amps. So I naught is equal to 6 amps when this inductor is 6 amps. So we know all of this. So when we plug in this equation, I naught is 6 e to the power minus r is equal to 8, L is equal to 2, T is equal to T. So the IT is become 6 into e to the power minus 4T. What is the purpose of these equations are? We need to find whatever we like. We can find the 4.5 millisecond, what is the IT? We can find the 2000 second, what is the IT for? That's the purpose of this. So this is the first part of this source free RL circuit. So we gonna look at the next part is source free RC circuit. Source free RC circuit. So we're gonna look at the source free RC circuit. So I'm going to draw the circuit for this. Very easy. The circuit is only one capacitor and has a switch and a resistor R. That's it. I just need to. So the capacitance of the C, and that's it. I'm just going to do the further move. So I'm just take this as a node and I'm put the nodal analysis. I put this IC and IR. I use nodal analysis. IC plus IR is equal to 0. For IC, what we have to do is C into dV over dt. If you already know, so if you don't know, you have to remember that the current through an capacitor is IC is equal to C into dV over dt plus IR is equal to V over R is equal to 0. So when we change this for a characteristic equation, dV over dt plus 1 over RC into V is equal to 0. For these types of equations as 1 over RC is equal to 0. So S is equal to minus 1 by RC. When we have these types of characteristic equation, we have the types of the answer for this. Vt is equal to A plus B into e to the power st. So we need to find the A and B. So when T is equal to naught, Vt is equal to, when T is equal to naught, Vt is equal to V naught. I put V naught. When we put t is equal to 0 in here, a plus b. So when t is equal to infinity, v is equal to 0 is equal to a. So a is equal to 0, so that v is equal to v naught. For the equation became for us vt is equal to v naught e to the power s is minus t into rc. So this is the equation which we are going to use in this circuit. So when we have a look at an example, we can find more explanation and more easy way. So I just need to do another example question. So if you understand this, please pause the video and do the question. 3 ohms, 9 ohms, and there is a 1 ohm, and it's a 20 millifarad a capacitor. It's have the V. So the question is, at t is equal to naught, the switch has been off. At t is equal to naught, switch has been off. Find Vt for t greater than 0, t greater than is equal to 0. So we already know that what is the answer for the Vt is V naught e to the power minus t over Rc. So Vt is equal to V naught e to the power minus t over Rc. Before that, we need to find is this source free RL circuit or source free RC circuit or second order or step response. What we have to find? First we need to find is this second order or first order. It is first order because there is only capacitor, there is no inductor. If capacitor and inductor in the same circuit, it's called second order circuit. So this is first order circuit, and there is no connection between the voltage source and the capacitor after t is equal to 0. So this is come under this source free RC circuit. So source free RC circuit, we know that Vt is equal to V naught e to the power minus t over Rc. So we need to find the V naught, that's t is equal to naught. What is the voltage drop across this capacitor and R and C? So C we already know 20 millifarad, and R we already know. Apart after the t is equal to 0, we don't need to consider this circuit. Only we need to consider this 9 ohm and 1 ohm. These two are series with the capacitor. So the R is equal to 10 ohms, and we know t is equal to 0. When t is equal to 0, the switch has been closed. So the switch has been closed means the current through this mesh. So when we use mesh analysis, we find that this has 4 voltage and this has 15 voltage. So V naught is equal to 15 voltage. So the answer comes Vt is equal to 15 e to the power minus t over 20 into 10 to the power minus 3 into 10. So the answer is 15 into e to the power minus t over 0.2. So when we solve this, if after this we can find t is equal to 10 second or 15 second or 1 hour or 2 hour, whatever. This is the second one. The next thing we need to do this, the third circuit is step response of RL circuit. Step response of RL circuit. Step response of RL circuit means there is a voltage source between the resistor and the inductor. So the drawing is come as this is Vs, and there is a resistor, there is a switch is here, and there is an inductor here. This is what we have to do. This t is equal to 0, the switch has been closed, and I note this, the current through this is I. So across this inductor is V. So what we have to do is, again we apply again we are going to apply the mesh analysis. That means Vs is equal to Vr plus Vl. So Vs is equal to Vr mean I into R. So Vl mean L into di over dt. I already told that. So when we solve this di over dt for the characteristic equation, see, because when we arrange as a characteristic equation, then we find our answer very quick and easily. So plus R over L into I is equal to Vs over L. So when we solve this, S plus R over L is equal to 0 because this is a constant. So constant became as 0. So S is minus R over L. So these types of characteristic equation, the answer became like IT is equal to A plus B into e to the power st. So t is equal to naught, the I value is I naught. I naught is equal to A plus B. So t is equal to infinity, I is equal to I infinity. That's mean I infinity is equal to A. So the B is I naught minus I infinity. So when we do the further, we came to a conclusion IT is equal to I infinity plus I naught minus I infinity e to the power 4s minus R over L into t. For this is the answer for the step response of RL circuit. When we do an example, we can come very brief understanding. So the question is, I'm drawing here, it's a 10 volt source and it's a 2 ohm resistor, and there's a 3 ohm resistor, and it has a switch, and it's an inductor 1 by 3 Henry. So the question is, find the IT for t greater than or equal to 0. So first, at t is equal to 0, the switch has been opened. So first what we have to do, I already told you, we have to analyze it is first order or second order or step response or source free, or what is the um, type of the circuit. So this is the first order circuit because there is only one inductor in here, there is no capacitor. So this is first order, and it's to the category of step response because when t greater than 0, the voltage source and the inductor has a connection. Voltage source and inductor has a connection. For this is step response of RL circuit. Oh, we already know, we already did. What is the answer for the step response of RL circuit? I infinity plus I naught minus I infinity. IT is equal to I infinity plus I naught minus I infinity into e to the power minus R over L into T. R over L into T. R over L into T. So when we need to find the IT, we need to find the I naught, I infinity, RL, and first we need to know I naught, I infinity, RL. We just easily find the L. L we know that 1 by 3, and R also we already know that this is 2 and 3 ohms. This is 5 ohms. And I notice when t is equal to 0, the I pass to the current going on this way because the t is equal to naught, the switch has been closed. T after the t is equal to naught, the switch has been open. So the I know, when we do a mesh analysis in this part, we find that I naught is equal to 5 amps. So I infinity, we find that when I infinity, we find that I infinity, we find that for I infinity, we find that this part, the current flowing on this part, this is 2 ohms. So the equation became IT is equal to I infinity 2 plus 5 minus 2 e to the power minus 5 over 1 by 3 into t. So IT is became 2 plus 3 into e to the power minus 15t. So this is the answer for this question. So the fourth one is the in the last one in the first order circuit. The last one in the first order circuit, that is step response of RC circuit. Step response of RC circuit. So step response of RC circuit became, this is a voltage source we here, and this is a resistor, and it's a switch and a capacitor with the capacitance of C, voltage is V. So I'm going to apply on T is equal to naught, the switch has been closed. So I'm going to apply the KVL. So Vs equal to VR plus Vc. So Vs is equal to VR I into R plus Vc as Vc I just put the V. So Vs is equal to, for I we already know that C into dV over dt, that's R extra plus V is equal to Vs. So when we arrange this as a characteristic equation, we come there dV over dt plus 1 over RC into V is equal to Vs over RC. So this is type of S plus 1 over RC is equal to 0. So S is equal to minus 1 over RC. So these types of characteristic equation, the answer for this Vt is equal to A plus V into e to the power St. So T is equal to naught, V is equal to Vt is equal to V naught. I take that. You can take A or B or C. T is equal to infinity. I took Vt as V infinity. So the answer became Vt is equal to V naught. T is equal to, no, V naught is equal to A plus V. V infinity is equal to A. So V naught, V infinity plus V naught minus V infinity into e to the power T over RC. That's a minus over here. So this is the answer for the VT, step response of RC circuit. When we have an example, we have more understand about our question. The question is, I'm going to write the question. It's 24 volts and 3 kilo ohms and 5 kilo ohms and there is switches here, and it's a capacitor of 0.5 millifarad. Let's have a process V, and it's 4 kilo ohms. In here there is another voltage source 30 volts. So at T is equal to naught, the switch has been switched into this switch. So what we are going to do, first we need to analyze its first order or second order or step response of source free or RL or RC. So this is the first order because there is only one capacitor, there is no inductor, only capacitor. Is a first order and is a step response because after T is equal to no, it's connect with this voltage source because it's a step response. For step response, what is the answer for that? Vt is equal to Vs plus V infinity plus V naught minus V infinity e to the power minus T over RC. So that is the answer for this. So we need to find the V infinity, V naught, R and C. We already know that the C part, the C is 0.5 millifarad, and we know the R when t is greater than, so I need to tell the question. It's very easy question. Find Vt after t greater than or equal to 0. So don't worry about the question. We need to follow these steps. Just remember the steps and understand the method. So R is after t is equal to 0. We know we don't need to consider about this circuit. We need to consider about this circuit. So R is only 4 kilo ohms, which has here. And we know at t is equal to naught, the voltage across this capacitor is equal to voltage across this 5 ohm, because at t is equal to naught, there is no connection between this switch. It's connection between this switch. So when we apply KVL, we find that the 15 voltage across the 5 ohm. So V naught is equal to 15 volt. V infinity, that's been after t is equal to naught. After t is equal to naught, we don't need to consider this switch. We need to consider this switch only. We need to consider this switch only. So when we apply KVL, we find that 30 volt, because there is no current through this path. This 30 volts drop across this capacitor, 30 volts, that is 30 volts. So when we solve the Vt is equal to 30 plus 50 minus 30 minus 15 e to the power minus t over R is 4 into 10 to the power 3 into 0.5 into 10 to the power minus 3. The answer is 30 minus 15 into e to the power minus 0.5 t. That's the answer for this equation. And thank you.